Good day. In this video, you're going to learn about calculations regarding light's wavelength. The wavelengths of light. The electromagnetic spectrum spreads over a tremendous range of frequencies of wavelengths. The wavelength in lambda is related to the frequency in terms of f. The speed of light, c, is equal to the product of frequency and wavelength, whereas your speed of light is always constant at 3 times 10 raised to 8 meters per second. Those electromagnetic waves that are visible or light waves have wavelengths that range from 0.00004 to 0.00007 centimeters. As you can see here, your red light is greater in amount of wavelength than your violet light, which means the spectrum of red is most abundant in our cosmos. We have the following table relating to frequency and wavelength of the following waves. We have gamma rays, X-rays, ultraviolet waves, infrared rays, short radio waves, broadcast radio, long radio waves. In this region, highlighted in red, is actually the color spectrum, which is only visible to our naked eye. The rest, gamma rays, X-rays, ultraviolet rays or ultraviolet waves, infrared rays, short radio waves, broadcast radio, long radio waves are invisible to our naked eye. Hence, red color or red light lies on the spectrum of 700 nanometers at wavelength, and we have the violets at 400 nanometers. The electromagnetic spectrum, a wavelength of 1 nanometer is actually equal to 10 raised to negative 9 meters. Once again, the speed of light c is equal to the product of frequency and wavelength, or your speed of light is always directly proportional to the product of frequency and wavelength. Let's proceed with the first sample calculation at light's helium-neon laser has a wavelength of 632 nanometers. What is the frequency of this wave? So we are given with a helium-neon laser with a wavelength of 632 nanometers. We are required to determine the frequency of the wave. So how are we going to do that? We had established that the speed of light is equal to the product of frequency and wavelength. If we're going to manipulate this equation to bring out frequency, this becomes the speed of light all over wavelength. If we're going to plug in the values, this gives us 3 times 10 raised to 8 meters per second all over 632 times 10 raised to negative 9 meters. Further simplifying the following terms gives us frequency value at 4.75 times 10 raised to 14 hertz. Hence, this lies on the red light spectrum. We have the second example. What is the frequency of oxygen spectral line if its wavelength is 530 nanometers? We are given with the wavelength of the oxygen at 5.13 times 10 raised to negative 7 meters. Okay. And then the speed of light always at 3 times 10 raised to 8 meters per second. So we are going to determine the frequency. The frequency now is equal to the ratio of speed of light and wavelength. We're going to plug in the values. The speed of light is again at 3 times 10 raised to 8 meters per second all over the given frequency for the oxygen at 5.13 times 10 raised to negative 7 meters. Further simplifying, this gives us 5.85 times 10 raised to 14 hertz. Now that ends my presentation for sample calculations of light wavelength. For further questions, you may message me through my messenger account or our LMS inbox.